So good evening all. Everyone can hear me? Online students, is my voice is loud and clear? Yes. Right, guys. So in the last class, we have discussed about the statistics. In the descriptive statistics, we have seen with respect to the shape. Okay, how to measure the shape. The shape is in terms of skewness and kurtosis. Okay, the shape with respect to skewness and kurtosis, and along with that we have seen with respect to the next one followed by percentiles, quartiles. In the quartiles we are having 25 percentile, 50 percentile, and next one is 75 percentile, that is Q1, Q2 and Q3. Along with that, we have discussed interquartile range. Interquartile range, that is IQR. IQR is given by Q3 minus Q1, right? That we have discussed in the last class. And using these percentiles and quartiles, we have worked on the next. We have seen with respect to box plot. And for box plot, we require the 5-number summary. And using that, box plot was designed based on the minimum value, Q1 value, Q2 value, Q3 value, and maximum value. Using these 5 values, we have designed the box plot, where the box plot is having with respect to this one, where the Q1, Q2, Q3, we are going to use the box, and with respect to minimum and maximum, we are going to use as the whiskers, right? And using the box plot, we are able to identify the outliers. And what is meant by outliers means any point which is distant or which is far away from the given data set. And we can identify based on the any value less than Q1 minus 1.5 into IQR is called as an outlier. Any value greater than Q3 plus 1.5 into IQR is called as an outlier. So these are with respect to the things which we have discussed in the last class, and how to calculate the outliers and how it is getting represented using the box plot means the points will be represented like this, right? So just it is going to calculate the value of this one. If any value is greater than this one, that will be converted as dot and remaining part will be taken as normal. For example, let us take a data set, a small data set where we are having 1, 1, 2, 2, 3, 4, 5, something we are having like this. Now inside this we are having with respect to the this is called as Q2. Okay, the center position value is called as Q2. Now whereas Q1 with respect to 1.5, the average of these two is 1.5, which is Q1. Now average of these two is 3.5, which is Q3. Now I'm having the minimum value for this data set. The minimum value is 1. Q1 value is 1.5. Q2 value is 2, Q3 value is 3.5, and Q4 value, that is maximum, is equal to 5. Assume that maximum value is 50. Still the Q1, Q2, Q3 will not change, right? In my case, the maximum value is 50 will be the remains constant because it is an order array. Now, what I'm going to do is, now Q1, Q2, Q3 you have calculated for the given data set, right? Fine. Now done. After using this one, now what you are going to do is just you are going to calculate Q1 minus 1.5 into IQR. That is Q1 is nothing but 1.5 minus 1.5 into IQR. IQR is nothing but Q3 minus Q1, which is nothing but 2. So which is 1.5 minus 3, that is minus 1.5. So any value less than minus 1.5 is considered as an outlier. In my data set, there is no value with less than 1.5. So left side, there is no outlier. Similarly, one more time, I'm calculating with respect to Q3 plus 1.5 into IQR. That is Q3 value is 3.5 plus 1.5 into 3.5 minus 1.5, which is 2. 3.5 plus 1.3, which is nothing but equal to 6.5. any value greater than 6.5 is considered as an outlier. So this value is considered as an outlier. So this is considered as a point. This will be kept as a point, and whatever the minimum value is that this minimum value and Q1 value, Q2 value, Q3 value, and the maximum value. Now the maximum value is equal to 4, and this will be the outlier. Like this, for this data set, this is the box plot representation. From this, we can understand there is an outlier. We can't identify what is the number. Using the box plot exact number, what is that number, sir, 50 or whether it is 500, that we can't see in the outlier in the box plot. In the box plot, we can see only one thing is with respect to some data point is there. Okay, in my data set, outlier is present. Whether outliers are present in my data set or not, only we can observe using the box plot. Okay, box plot is used to identify whether the there is outliers or not. That's it. Yes or no. What value is there? How many are there? These things we are not going to use the box plot. So whether outliers are present or not. Okay, box plot is used to identify. What is the use of box plot? Means it is used to identify whether outliers are present or not. Yes or no. If outliers are present, means according to that we have to do the data cleaning. If outliers not present, means according to that we have to follow the next step. Okay, to check whether the outliers are present or not, only we are saying using the box plot, right? So if, for example, in the box plot you are having like this. Okay, now here there is a dot, one more dot, one more dot, one more dot, one more dot, 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 dot. Like this, dots are there. Multiple dots are combined each other. Now here, how many dots are there within this? We are not focusing on that. How many dots are there? How many outliers are there? We are not focusing like this. Just only one thing is dots are there or not. Dots are there means outliers are there. Outliers are there means we have to clean the outliers. If outliers are not there means no need to do the cleaning step for that one. Is that clear? So box plot is used to check whether the outliers are present or not. Nothing else. Right? Q2 is nothing but equal to its mean. Right? Any value greater than, in the previous example, whatever the previous example you have considered, in that previous example, any value greater than 6.5 is considered as an outlier. Any value less than minus 1.5 is considered as an outlier. Okay. Now, the next one is called as covariance. Okay. Next one is called as covariance. Covariance means, now tell me what is the formula for variance? Sample variance. What is the formula for sample variance? Sigma of x minus x bar whole square divided by n minus 1. This is for sample variance. Now, what is meant by this one? Nothing but x minus x bar into, once again you are doing x minus x bar, right? Divided by n minus 1, right? So you are doing just sigma of x minus x bar into x minus x bar divided by n minus 1. That is nothing but sigma of x minus x bar whole square divided by n minus 1, right? Now for here, so this, if you go with this one, it is variance of single variable. This is the variance of a single variable. Now if you want with respect to two variables at a time, the second variable, instead of considering x, you have to consider the y. Change this one to y. Right? So example 1, 2, 3, 4, 5. You are having 5 points like this. For this, what is the average value? X bar is equal to 3. Let us assume this is x and x bar is equal to 3. Now you are going to calculate x minus x bar. That is 1 minus 3, minus 2, minus 1, 0, 1 and 2. Now x minus x bar whole square. What is meant by whole square? Doing the same thing, multiplying the same thing into 2 times. That is x minus x bar into x minus x bar. So minus 2 into minus 2, which is nothing but minus 4. Sorry, plus 4, plus 1, 0, plus 1, plus 2. Now you are doing with respect to plus 4. Now you are doing with respect to sigma of x minus x bar whole square. What is the meaning of this? Adding all of this, that is nothing but 10. Divide by n minus 1, nothing but 5 minus 1, which is 4. 10 by 4, 2.5 is the variance for this particular data. For this data set, the variance is 2.5 for this data set. For this data set, the variance is 2.5. Now the same thing for single variable you have calculated, fine. But I don't want for a single variable. I want to calculate for two variables at a time. How the variation of one variable is having on the other variable. I want with respect to one to other. How much the variation of one variable with respect to second variable. For example, I'm having x is one of the column where 1, 2, 3, 4, 5 is there. Now I know variance of x single separate it is 2.5. But I want with respect to the second one. For example, I'm having 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Now, I want to identify the covariance of x comma y. What is meant by covariance of x comma y means variation of x with respect to y. Variation of x with respect to y. You are saying with respect to variation of y is called as covariance. How much x is varying with respect to y. Now here you are going to calculate with respect to covariance, that is nothing but x minus x bar. That is nothing but first you are going to calculate x bar, which is nothing but 3. X minus x bar is 1 minus 3 minus 2 minus 1 0 plus 1 plus 2. Next one is y minus y bar. First y bar is equal to 8. Again minus 2 minus 1 0 plus 1 plus 2. Now you are going to take x minus x bar into y minus y bar. And if you consider these values, now you are going to have with respect to minus 2 into minus 2 plus 4 plus 1 0 plus 1 plus 4, which is equal to 10. 10 divided by n minus 1, that is 2.5. Covariance is 2.5 for this data set. Since I have considered the values like that, sir, variance of x and covariance of x and y, I'm getting both of them same, because how you are having this one, the same thing is you are also having here also same now. This from this value was increased only one value. All the values has been increased one. So that is the reason you are having both of them as same. For example, you are having here the first value as, now let us take the same thing. Let me show you in the pandas. Okay, you are taking this one in this descriptive statistics. Descriptive statistics. So covariance, how to calculate the covariance? Yes. So what I'm going to do is just I'm going to create. Okay, let me create a new one. Forget about this. Okay, let me show you with a simple example. Like first one, I'm going to create data frame is equal to pd dot data frame of, I'm going to use dictionary where x is the key name, that is column name of x, and the values I'm going to give as 1, 2, 3, 4, 5, and this should be as a list. So I'm going to take this one as a list. Okay, and this I'm going to print df. So pandas is not defined. So import pandas as pd. So you have got the values like this. Now within this, how to execute a single column? You can get a single column by accessing this one dot variance. If you ask with respect to variance, you will get with respect to the variance is 2.5. How the variance is calculated, I have shown you right just now. That is x minus x bar, sigma of x minus x bar whole square divided by n minus 1. By default, it is going to consider that one as a sample variance. Right? Now, next one is I'm going to take one more variable called as y. Let us take one more variable with respect to y. And in this variable, I'm going to give the list of values, 6, 7, 8, 9, 10. Okay. Now I'm executing the data frame. Now this is the data frame where I'm having two columns. Now what I'm going to do is I'm going to apply df dot covariance. Instead of variance on single variable, I'm applying covariance. Now I have got with respect to the variance of x comma x here, variance of x comma y, and variance of y comma x, and variance of this one. Now let us change this one to here. Instead of this, I'm considering first value of Let us go with some value. Which one? Which will be easy for calculation purpose? 6 plus 7, 13, 13 plus 8, 21, 30, 40. 40 divided by 5. So 5 you have to get miss. Okay, 16. Let me go with 16. Now can you calculate manually? 1, 2, 3, 4, 5, 16, 7, 8, 9 and 10. Can you calculate the covariance between both of them? That is, what is the x bar? 3. And what is the y bar? 50 divided by 5, which is equal to 10. So 16 plus 7, 23, 23 plus 8, 31, 31 plus 9, 40, 40 plus 10, 50. 50 divided by 5, which is 10. Right? Now I'm going to apply x minus x bar. That is minus 2, minus 1, 0, plus 1, plus 2. Now y minus y bar, plus 6. Next 7 minus 10, minus 3. Next minus 2, minus 1 and 0. Now I'm going to multiply these two, which is minus 12 plus 3, 0, minus 1, 0. That is x minus x bar into y minus y bar. Now I'm going to do the summation of x minus x bar into y minus y bar. That is, sum is nothing but this one. Minus 12 plus 3, minus 9, minus 9, minus 1. So you're going to get minus 10. Divide by n minus 1. N minus 1 is nothing but 5 minus 1, that is 4 minus 2.5. So let's give it a try. You're going to get minus 2.5. Now this particular value indicates it is covariance of x comma x. This is covariance of x comma y. This is covariance of y comma x. This is covariance of y comma y. Covariance of x comma x is nothing but variance of x only. Covariance of x comma x is equal to variance of x. Can you calculate variance of x for this? That is minus 2, minus 1, 0, plus 1, plus 2. Whole square is nothing but 4, 1, 0, 1, 4. Total is 10, 10 by 4, which is 2.5. That is variance of x. Now can you calculate similarly variance of y? What is variance of y? Here, whatever the values are there, whole square. First one is 36. 36 plus 9 plus 4 plus 1 plus 0. That is 45, 49, 50. 50 by 4. 50 by 4 is nothing but 12.5. So this is nothing but 12.5. Is that clear? Manual calculation along with the code. Both are okay? Clear, guys? So just covariance is nothing but variance of x comma y. How much variation of x is there with respect to the y gives the covariation. Now, if the covariance is positive, okay, sir, covariance we have calculated. You are showing the max. Now, what is the use? Here, the max is not important. After the max, you have got the value now. With that value, what you are understanding, that is data science. If you do up to here, it is called as max. After this, if you understand, that is called as statistics. Till now, we have done the max. Formulas we have substituted and we have done the max. Now statistics. Statistics in terms of if the covariance of x comma y is positive. Positive means both are proportional to each other. X is directly proportional to y. If the covariance is x comma y is negative, x is inversely proportional to y. Both are inverse. Inverse means as x increases, y decreases. Directly proportional means as x increases, y also increases. Example, as one of the student in the chat box is asking, and some of the students are seeing in a faster way that I am explaining in a fast way. So for them, once again, I am explaining in a different example, x comma y. Now 1, 2, 3, 4, 5. Y 6, 7, 8, 9, 10. Now, if you make a plot between this one, first 1, 6, this is the point, 1, 6, 2, 7, 3, 8, 4, 9, 5, 10. As x increases, as x value increases, y is decreasing or increasing? Okay. Now calculate for this particular data set, calculate the covariance. calculate the covariance. I don't want the value, whether it is a positive or negative, just tell me that one. Okay, now take with respect one more example with x and y. 1, 2, 3, 4, 5. This time 10, 9, 8, 7, 6. Just opposite. Now as x value increases, y is decreasing or increasing? Now you calculate the covariance. Calculate the covariance for this, calculate the covariance for this. Now you tell me. For the first one, I am calculating the covariance, that is x minus x bar, that is 1 minus 3, which is minus 2. 2 minus 3, minus 1. 3 minus 3, 0. 4 minus 3, plus 1. 5 minus 3, which is plus 2. X bar is 3. These are the x values. Similarly, y minus y bar, that is 6 minus 8, minus 2. 7 minus 8, minus 1. 8 minus 8, 0. 9 minus 8, 1. 10 minus 8, plus 2. Now, you calculate the x minus x bar into y minus y bar. That is multiplying these two values. Minus 2 into minus 2, plus 4, plus 1, 0, plus 1, plus 4. Now you do the total. Total is nothing but 10. Divide by n minus 1, which is nothing but 4. You have got 2.5, which is positive. Since the x value and y value both are directly proportional to each other, you have got the positive value. Now let us take in the second example. Example number 2. Calculate once again x minus x bar. That is 1 minus 3, once again minus 2. 2 minus 3, minus 1. 3 minus 3, 0. 4 minus 3, plus 1. 5 minus 3, plus 2. Next, y minus y bar. Y bar is, once again it is 8 only. 10 minus 8, which is plus 2. 9 minus 8, plus 1. 8 minus 8, 0. 7 minus 8, minus 1. 6 minus 8, minus 2. Now you multiply with x minus x bar into y minus y bar. Now minus 2 into minus plus 2, which is minus 4. This one, minus 1, 0, minus 1, minus 4. Total, minus 10. Divide by n minus 1, which is nothing but 4, minus 2.5. Got the point? If the covariance is positive, indicates that x and y are on the same trend. As x increases, y also increases. If the covariance is negative, as x increases, y decreases. If the covariance is 0, then there is no relation between both of them. Then there is no relation. Both of them are not having any kind of relation. Right? Is that clear? If the covariance is positive, means both are directly proportional to each other. If the covariance is negative, means both are inversely proportional to each other. Inverse means as x increases, y decreases. Right? So from the covariance, we can say that whether as x increases, y is increasing, or as x increasing, y is decreasing, that we can identify based on the covariance. Right? For example, if you are preparing every day instead of 1 hour, 2 hours, 2.5 hours, 3 hours, 4 hours, you are increasing your time. As you are increasing more time, how much salary you are increasing? It is directly proportional or inversely proportional, miss? Just you calculate the covariance. Just you calculate the covariance. As years of experience versus your salary. Take years of experience on the x, salary on the y. Calculate. Covariance we will get as positive, means as the salary, as the experience increases, salary increases. Just we want the whether it is positive or negative only. We don't want the value, whether it is a 2.5 or 10.5 or 19.5 or that is secondary. We want only sign, whether it is a positive sign or negative sign. We don't focus on the value. We'll focus only on the sign. Sign says that direction. Whether it is a positive, miss plus value. If you got the covariance as plus, miss, it is indicates that it is a positive direction. Positive direction meaning is x is directly proportional to y. As x increases, y also increases. If the covariance is negative, that is called as negative direction. Negative direction means x is inversely proportional to y, means X increases, Y will decrease, and vice versa. That is the importance of covariance. Now it is clear. Now how the Y variable in terms of second variable, how it is impacting based on the first variable. What is the relation between these two variables is given by covariance. Now this gives the relation, whether they are positive relation or negatively related, but how much strongness they are having. How much strongness they are having. Okay. Sir, for example, as the salary and your experience, as experience increases, salary increasing, sir. Okay. With what percentage? How much they are correlated? 100%, 80%, 90%, how much? How much it is increasing? Value, how much value it is increasing? That gives based on the correlation. That is correlation. Correlation is just, it gives the relation between two variables. Relation between two variables in terms of value wise. Okay. Now, if you see the covariance, whatever the covariance is there, what is the range of covariance? What is the range, you know? Range is from minus infinite to plus infinity. Anything can be there. The covariance can be anything from minus infinite to plus infinity. Whereas correlation will have the range from minus 1 to plus 1. The correlation range is from minus 1 to plus 1. Correlation range is from minus 1 to plus 1 with square brackets, where minus 1 also included, plus 1 also included. Okay. So now correlation is denoted by the letter called as small r. It is given by the letter small r. And the formula was given with respect to like this. Correlation, which is nothing but r, is equal to covariance of x comma y divided by standard deviation of x into standard deviation of y. Right? Now, nothing but covariance. What is covariance of x comma y formula? Sigma of x minus x bar into y minus y bar divided by n minus 1 whole divided by square root of sigma of x minus x bar whole square divided by n minus 1 into sigma of y minus y bar whole square divided by n minus 1. Now, without writing, please observe this one. So, whatever you are having here, the square root, can I write the square root to the upper one and to the lower one separately? This one and this one also separately. Now, if I multiply these two, square root of n minus 1 into square root of n minus 1, it is nothing but n minus 1, and this one will be cancelled. And now the formula is sigma of x minus x bar into y minus y bar divided by sigma of x minus x bar whole square into square root of sigma of y minus y bar whole square. Whatever you are saying here, that one. Okay, from where you got this equation is based on this one. Covariance of x comma y divided by standard deviation of x into standard deviation of y. Just substitute the form inside that formulas and you will get this one finally. Both are same. Right? Now both of them tells about how much strong they are correlated. Okay, for example, let us take two members are there, x and y. These are two persons, person number x or person number 1. Let us take person 1 and person 2. Two persons are there, person 1 and person 2. Now either they will be friend or they will be enemy. Right? So something will have no relation. With no relation. Whoever is sitting in the last bench, whoever sitting in the first bench, these both of them are not having any kind of correlation. The relation between them is 0. They don't know their faces also to each other. After going down, oh, you belongs to data science batch only, yeah? Okay. I also belongs to that one. They have to discuss like this. They don't know each other. Whereas now whoever sitting side by side, they are with respect to friends. Next day, please come and sit here. You are writing very nicely notes. I can copy on yours, right? So this friends will be there, right? Either friend or enemy. Friend with respect to positive correlation. Enemy means with respect to negative correlation. Now, how much friendship is there? For example, you and your friend very close to each other. Very, very, very close to each other. Wherever you go, you both will go. Assume, right? Assume in that way. Now, for example, in that, one of your friend was absent today. Whether you will be absent? If you are absent, means correlation is 100%. If you are not absent, means there is not that much of correlation is not there. Right? Your close friend is absent today, means you should also be absent, right? Then you are having a very high closeness. That is correlation. Example. This is pure example. Here, the thing is that percentage of relation, the percentage of relation is given by the correlation. Correlation says the percentage. How much percentage? That is, for example, 0.9, you have got as 0.9 means 90% they are correlated. 1 you have got means 100% they are correlated. 0.6 you have got means 60% they are correlated. 0.1 means 10% they are correlated. 0.05 means 5% they are correlated. Just percentage of relation between the two variables. Percentage of relation between two variables. The relation can be either positive relation, at the same time negative relation. Example, as for example, let us take, as the cc of the bike increases, what happens to the speed? Let us take the speed. The speed increases or decreases? Increases. How much they are correlated? 100% they are correlated. As you increase the cc, perfectly you can clearly see in your speed. Okay, if the more cc is there, means more speed you can get, more pickup you can get easily. They are 100% correlated. At the same time, as the cc increases, mileage also decreases. This is also 100%. But in a negative way. Negative way. Now what happens as the cc increases? What happens with respect to the weight of the bike? Increases or decreases? Here the percentage will be with respect to different, not with respect to 100%. That is going to be having some percentage, not 100%, right? Whereas we are having the relation in the both the directions, either in the positive direction, in the same time in the negative direction also. Okay, so the relation between two variables you are having with respect to very close relation, 100% correlation means with respect to you are going to get R value is equal to 1. So the R value is having from -1 to +1. This is the range. This is the range of R value, that is from -1 to +1, right? Where you are going to have the, for example, you are having the R value is equal to -0.9. What is the meaning? It is having 90% correlation, but in a negative direction, in an opposite way. The relation is in the opposite direction. Got the point? So if R value is equal to +0.8, 80% they are correlated in a positive way. Plus indicates the direction. This indicates percentage of relation. Got the point? Is that clear? So now if you take this one, 1, 2, 3, 4, 5. This one 6, 7, 8, 9, 10. Now if you take this one, now if I calculate the correlation, if I get the correlation, now just calculate the correlation. In this case, you are going to get the correlation is equal to 1. Perfectly 1. That 2 plus 1. Why plus 1 you are going to get? Because perfect correlation you will have. Perfect correlation means each and next point 6 means here you can clearly say it is 11. That much of perfect correlation. For example, now let us take in the same example. Okay, sir. Let us take one this one. Now 9.9. Now once again, as the x increases, y is increasing, everything is same. Now with respect to what is the correlation means, this time you are going to get 0.99. 99% they are correlated, not with 100%, because small difference, slight difference is there. Right? So if you calculate this one, see now I'm calculating here I'm taking the same values. I'm giving with respect to 6, 7, 8, 9, 10. I'm creating the data frame and I'm asking with respect to the correlation quotient, double R. And I'm getting the correlation as 1. The relation between X and X is 1. The relation between X and Y also 1. I'm getting as a matrix format. Okay, in a matrix format where for each variable to other variable also I'm getting. Is that clear? Now in the same thing, for example, I'm writing here 10, 9, 8, 7, 6. Okay. Now you are having the data set like this. Now if you calculate the correlation, you will get once again the correlation is equal to exactly 1. But in a negative direction, which is minus 1. The correlation between X and Y we will get as minus 1. This says the correlation between X and Y. This says the correlation between X and X. Always the relation between X and X will be always 1. Because covariance of X comma X, which is nothing but variance of X. In the denominator, that is standard deviation of X into standard deviation of X. 2 times if you multiply standard deviations, what happens? It is nothing but variance of X only. Denominator variance of X, numerator also variance of X. Always it is equal to 1. Always it is 1. Right? So you are going to take diagonal elements as equal to 1 and upper triangle and lower triangle is going to be the same. Is that clear, guys? That is correlation. Correlation means relation between two variables. Covariance means direction between two variables. Covariance gives you the direction. Covariance gives you the direction. Correlation gives you the strength. Correlation gives you the strength. Strength means how much percentage they are correlated to each other. One gives you the direction, one gives you the strength. Okay. If the higher the close correlation is there, the prediction will be very easy. For example, let us take like this. We are having in the stock market, we are having concept called as, again it will be deviated. Okay, let us go with another example. Another example, yeah, in the summer, the sales of ACs. In the summer, the sale of ACs, and in the same thing in the winter, the sales of heaters. Okay, if you see this one, these both are having a strong correlation, a good correlation. Okay, this both will have the good correlation, but these both will have with respect to less correlation, or with respect to negative direction. With respect to this one, less correlation. Just based on the correlation, we can have more easily the prediction also. If the correlation is very high, we can easily predict the next value. For example, if here we have got very strong correlation. For example, next 6 is there. What is this value? Obviously, it is 5 only. If it is 7 means this one. If it is 8 means this one. So you can easily identify this one. But for example, out of this, now for example, here you are having 5 and this is 6.1. For 6, what is the expected value? It can be with respect to 5.9 or with respect to 5.1 or 5.01 or 5.02, anything, right? You can't predict that much of perfectly. So if the perfect correlation is there, means perfect answers we can predict. Now within the correlation, if you are having the correlation with respect to 0, means it is says that there is no correlation between both of them. If it is plus or equal to minus 1, means it is a perfect correlation. So in the real life, we are going to use the mod of R. We are not focusing on the plus or minus, we are focusing on the value. Plus or minus, we are focusing in the covariance. In this correlation, we are focusing on the value. So now the value, if it is equal to 0, means no correlation. The meaning is no correlation. If the mod of R is less than or equal to 0.5, means it is less correlated. They are having the less correlation between two variables. If the modulus of R between 0.5 to 0.8, then it is called as moderate correlation. Then it is called as moderate correlation. If the correlation is greater than or equal to 0.8, it is called as strong correlation. This is called as less correlation or weak correlation. Simply you can say as weak correlation. And based on the correlation, we are going to ignore the futures. For example, I want to predict your salary as a data scientist. Okay. I want to predict as a data scientist salary. That is output I want to predict. For that, what are the futures I'm having as the input futures? Means your age, education, skill set, years of experience, number of projects, and your date of birth or something. I'm having all these things, out of which is having low correlation, that I'm not going to consider. Which is having very strong correlation, that I'm going to consider. Which is having strong correlation means your projects are having with respect to strong correlation. Your data science experience is having with respect to strong correlation. So we are identifying the high correlated variables, and based on that, we are able to predict the data scientist salary. Whichever is we are having the less correlation, that particular variables we are going to delete in the further class. This correlation is going to be useful as the one of the future selection. Means which variable is important or which variable is not important for predicting the output. In that case, we are going to use this correlation concept. Right? Next one is called as probability. Okay. So now probability means everyone will think that intermediate max probability, again balls with respect to toss, again dice. No need to think that much of. Here we are going to see probability related to data science only. We are not going with IIT exam, entrance examination. We are not going to become as a mathematician. We don't require that much of max of probability. We require only the basics of probability. Right? So now probability means, what is the meaning of probability means? Chance of occurrence. Chance of occurrence. Next, this is the meaning. Now how to calculate the probability? Probability is nothing but in your data, how many are satisfying your condition? How many of them are satisfying your condition divided by total number of data points. Total number of data points and number of data points satisfying your condition. Your condition is called as probability. For example, there is a data set called as 1, 1, 2, 3, 4, 5, something I am having. Now, what is the probability if you select a number from the given data set? If you select a single number, that number is less than or equal to 5. How many numbers satisfies your condition here? 1, 2, 3, 4, 5, 6. 6 numbers satisfies. How many out of 6 numbers? Means 100% probability. Now, for example, if I am asking the same question with respect to less than 5, how many numbers are satisfying your condition? 5 numbers, that is 1, 2, 3, 4, 5. These 5 numbers only satisfy your condition. 5 divided by 6. This is the probability. Now, if I write the probability with x is equal to 0, how many of the numbers are satisfying your condition? 0 numbers. Out of 6, the probability is equal to 0. Right? So here the value, the minimum value you are going to have from 0 and the maximum value you are going to have with 1. If everything satisfies also, 6 by 6 only, denominator will be the maximum value. You can't get the numerator maximum of denominator. Denominator is the total. If both are equal means 1. Then denominator in the numerator you can't get the more value. Na? If how many numbers are satisfying, how many things are satisfying means either you will write with respect to 4 or 3 or 2 or whatever it is number. If none of them satisfying, 0 only you will write. You can't write the negative also, right? It is not possible to write the negative because the numerator is a count. It is counting. How many of them are satisfying your condition? Counting. How the count can be negative? The count will be either 0 or with respect to whatever the number. If none of them is available, means 0 count. Right? Now here, if you are having with respect to toss, okay, you are taking a coin and you are tossing a coin with respect to heads and tails. What is the probability of head miss? What is the total number of outcomes you are having is 2 only, either head or tail. You are having 2 is the maximum. Out of head is 1. With respect to tail miss 1. This is the basic example in the probability. Now within this, if I am asking what is the probability of getting with respect to called as HT, that is a new variable HT. Either heads is possible, either tail is possible. What is this HT? It is not possible now. 0 by 2, that is not possible. That is not there in the given. So probability is 0. If the probability is there, means probability value. If the probability is not there, means 0. Simple. If that particular thing is not available, 0. Now, if you are rolling a die, second example, rolling a die. Now, what are the possibility outcomes you are having in this? Either you will get 1, 2, 3, 4, 5, 6. Only these are the 6 maximum outcomes. Maximum number of outcomes is denominator 6. Fix. Now, based on your question, what is the probability of getting 1? How many options are there? One option only is there, 1 by 6. What is the probability of getting 2? 1 by 6. What is the probability of getting 3? Exactly 3. How many satisfies that one? 1 by 6. How many of them probability satisfying less than 4? 3 are there. 3 by 6, which is probability of 1 by 2. How many of them are satisfying? Divided by total number of outcomes is called as probability. Is that clear? First, you have to list out the list of outcomes. Whatever the possibilities are there, first you list out that one. Within that, based on your condition, how many are satisfying is the probability. For anything, for any data set, the same thing. Now, here with respect to the probability of x is equal to 3 is 1 by 6. What is the probability of x is equal to 4? 1 by 6. Probability of x is equal to 5? 1 by 6. Probability of x is equal to 6? 1 by 6. If you do the sum of all the probabilities is equal to 1, which is equal to 6 by 6, which is equal to 1. Sum is equal to 1. All the probabilities for each of them separately you calculated the probability. Total is 1. Similarly for head and tails, toss. In the toss you are having only 2 options. List of outcomes, first you list out. These are the possibilities. These are the only 2 possibilities. There is no other possibility. Now for this list of possibility, for each of them calculate the probability. For P of H, 1 by 2. For P of T, it is 1 by 2. Now do the sum. Sum is equal to 1. Always the sum of the probabilities is equal to 1 only. Every time the sum of the probabilities is equal to 1. And always the probability lies between 0 to 1. The range of probability between 0 to 1. Where 0 is possible, 1 also possible. The maximum probability is 1 and the minimum probability is 0. Never the probability can be negative. It is not possible. Now, let me explain with a very simple example. Right? Let me explain with one more example. Here, you are having a pack of cards. So, I think everyone knows the cards. Right? I'm not asking whether you know Rummy or not. I don't want that one. Just you are familiar with cards, right? So, in the cards, we are having total 52 cards, out of which 26 of them are red color and 26 of them are black color. So out of which in the black, again 13 cards we are having with respect to color and spade, and with respect to whereas red colors we are having heart-in and diamond. These are the different shapes. Each of them are having 13, 13, 13, 13. Where A is considered as 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Jack is considered as 11. Queen is considered as 12. King is considered as 13. Right? For anything. Right? Don't ask, sir, A also considered as 14. Nah? I'm not playing Rummy. So it is not considered as 14. So basic only I'm explaining. So this is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Jack is considered as 11, 12 and 13. King is considered as 13. Right? If you are playing Rummy, miss, A is considered as 14. Right? If you're not playing Rummy, miss, A is not considered as 14. Now here we are having, now tell me, how many cards? Total, how many cards are there? 52 cards. Now tell me what is the probability that I select one card from this out of 52. I'm going to select one card randomly. I'm going to choose. What is the probability that it is going to be greater than 10? The condition which is greater than 10. How many cards are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 cards satisfies your condition. So you're writing 12 by 52. That's it. This is the maximum possibilities for everything, out of which 12 of them are satisfying your condition. Whatever the condition you have written, that one is satisfied by 12 of them. So 12 by 52. Is that clear? Probability. Now, how many of them are satisfying, which is greater than or equal to 10? So additional these 4 cards also will be added. That is 16 by 52. How many cards are satisfying less than 3? 1, 2, 3, 4, 5, 6, 7, 8. 8 cards divided by total is 52. Now, how many cards are satisfying the condition of x is greater than 4 and less than 8? That is 5, 6, 7. 12 by 52. Right? Just first you have to list off all the outcomes you have to list here. Don't ask about the joker. Without joker, this is the cards. Pack of 52 cards. There is no joker is included in this. Right? Now here we are having the pack of 52, out of which, based on the condition, how many cards are satisfying. Is that clear? The probability is clear. Now in this class, I am going to take the heights of each and every student. Every student height I am going to consider. In the offline, whatever the students are there, first student says that my height is 5.5, sir. 5.6, 5.7, 5.6. One more student will say 5.6. One more student 5.6. One more student 5.6, 5.8, 5.9, 5.10, 5.7. Something I have got like this. Now, just I'm going to consider the heights, and from this I'm going to calculate what is the probability that student height is greater than 6. How many students are greater than height 6? In this case, it is 0. 0 by 1, 2, 3, 6, 9, 10. 10. So just list off all the things, whatever the possible outcomes are there, just list out them. In that, check your condition, how many of them are satisfying. Whichever satisfying your condition, write the count on the numerator divided by total number of data points is called as probability. Is that clear? Probability is clear. This is the basic of probability. Now we'll see the theorems in the probability. Okay. Again, theorems means don't think too much. Again, it is also going to be very simple. Final answer is going to be hence proved. Okay. So now out of which we are going to get A and B are two independent events. What is meant by independent? Independent means they are not connected to each other. Selecting of this one is different. Selecting of the second one is different. For example, in this class, I want to select one student. Okay, I'm selecting one student for asking one question. For example, I have selected this first bench first student. Okay, assume I have selected this one. Now, the second question, first question I have selected him. Second question, I'm going to select the second person. Is there any connection between, since I have selected this person, second question I have to select only from the goals? Is there any rule like that? If there is no rule, then it is called as independent. If there is a rule like that, then it is called as dependent. Got the point? Dependent events means they are dependent on each other. The first one, the second one is dependent on the first one. Since you have selected, I have to, for example, I want to ask the questions alternatively. One for boys, one for girls, one for boys, one for girls. Now, first one I have asked for boys, automatically the second one should be girl only. Obviously, I have to ask. If I ask first one for the girls, automatically the second question, I have to ask for the boys. There is a condition. There is a condition like that, then it is called as dependent events. If there is no relation between both of them, you can ask anyone. Either first question you can ask boy, second question also boy, third question also boy, fourth question also boy, fifth question you may ask girl. If there is no condition like that, then they are called as independent to each other. There is no relation between both of them. If they are independent to each other, then we are having both probability of A and B is equal to probability of A into probability of B. Probability of A into probability of B. Now let me explain this example with taking probability of A, that is nothing but probability of selecting red color. A is nothing but selecting the red color. Now tell me, out of 52 cards, how many red cards are there? 26 cards. 26 by 52. Probability of A. A is nothing but red. Probability of B is nothing but probability of selecting 9. Tell me how many cards are satisfying with 9? 4. 4 by 52. Right? Now probability of A and B. What is the meaning of A and B? A probability of red and 9. A card should be such a way that it should be red along with that 9. How many cards are there? How many cards are satisfying this condition of red and 9 in this total? 52. Red, what is meant by end? End means both the conditions should be true. How many cards are there? 2 cards. This is first card, this is second card, which satisfies your condition. That is probability of getting red and 9 is nothing but 2 by 52. Probability of red is equal to 26 by 52. Probability of 9 is nothing but 4 by 52. 1, 2, 3, 4. This is separate, that is separate. Each of them are separate. Everything are separate. Now, if you take this one, probability of red and 9, which is 2 by 52, I'm multiplying the probability of red into probability of 9, which is nothing but 26 by 52 into 4 by 52, which is nothing but this one 2 times, this one 2 times, which is 2 by 52. Both are equal. Probability of A and B is equal to probability of A into probability of B. Condition satisfied, hence proved. LHS is equal to RHS. Theorem completed. Any questions? Probability of red and 9 is equal to, that is probability of A and B is equal to probability of A into probability of B, if both are independent to each other. This condition applies only when they are independent to each other. If they are dependent to each other, this condition is not applicable. Is that clear? Mind-blowing explanation, huh? Okay, good. Clear, right? For you it is clear, right? Done. Now let us go with the probability second one. That is probability of red or 9. Now I want to select out of these 52. Tell me how many cards satisfies either red or 9. Anything is okay for me. How many cards satisfies that one? 28. Because these are the 26 cards. Along with that, these 2 cards also. Already here you have selected these 2 cards. Again, you can't add this one. Now out of 52 cards, 28 cards will satisfy your condition. That is 28 by 52. Now probability of red plus probability of 9 minus probability of red and 9, which is equal to 28 by 52. Sorry, 26 by 52 plus 4 by 52 minus 2 by 52, which is 26 plus 4, 30, 30 minus 2, 28, 28 by 52. So now probability of A and B, sorry, A or B, the probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Hence proved once again. That is one theorem. This is one theorem. One is called as multiplicative theorem. One is called as additive theorem. These both theorems will be asked in the certification, not in real life. In the TCS exam, they are going to ask this question. That is the reason I have explained this one. In real life, everything will be done using the algorithms by using the libraries. Coding is very simple. Theory part only difficult now. Coding just in one line you can complete. Is that clear, guys? So you are having with respect to probability of A and B is equal to probability of A into probability of B. This is called as multiplicative theorem. Probability of A or B is called as probability of A plus probability of B minus probability of A and B, which is called as additive theorem. I have shown you with example. Now it is clear. Completed. Probability over. For entire data science, probability is completed. Today is the starting day. Today is the ending day for probability. Never we are going to discuss the probability except one day. Because based on the probability, one algorithm is there. At that time, we'll discuss. Based on the correlation, one algorithm is there in the machine learning. At that time, again, correlation will come into picture. This is the basic probability only. No need of number of black bars, red bars. We are having this many bags. What is the permutations, combinations? Nothing is required for data science. This is only the max we require. Max related to data science is completed from probability perspective. Right? Only nav-based theorem. Exactly. Nav-based theorem is there. That will work based on the probability. At that time, we have to discuss that algorithm will work on the probability. Is that clear, guys? Now, next one is called as probability distribution. Probability is completed. Probability distribution is left. Okay. So next one is probability distribution. Probability distribution is just very simple. Okay. Probability distribution is nothing but graphical representation of variable and their respective probabilities. Down on x-axis, you have to take the variable name. On the y-axis, you have to represent their probability values. For example, let us take a simple example. Very simple example. Gender. M, F, M, F, M. 3, 6, 9, F. Okay. Right? Now, in this, tell me how many Fs are there? 4. What is the probability of F? 4 by 10, which is 0.4. M, 6 are there. What is the probability of M? 6 by 10, which is 0.6. This is called as probability. Now, distribution is nothing but denominator write M and F and their respective probability of 0.6 here and 0.4 here. This is called as probability distribution. This is probability distribution. Up to what height you have to draw, miss? Up to what value is there? That much of height you have to draw the bar. If the probability is 0.7, miss, up to 0.7 you have to draw. If probability is 0.4, miss, 0.4. Up to what height? The variable on the x-axis and the probability on the y-axis is called as probability distribution. This is the data. This is the distribution of the data. Clear? Now, once again, this time some comparatively slow motion. Let us go in a slow motion. Okay. Now, let us go with, this is a data. This data you are representing in a tabular format like this. This is the gender and the count. Male and female. Males are 6 and females are 4. This is called as frequency table. The name is called as frequency table because here you are having frequency. Count is nothing but frequency. Frequency or table count both are same. Frequency means count, count means frequency. Both are same. This is called as frequency table because here in this table, it is written with respect to how many counts are there. This is the tabular format. This is called as frequency table. Now this, if you represent like this, on the males with respect to 0.6 and females with respect to 0.4, this is called as frequency distribution. This frequency distribution is also called as probability distribution. Now, what is the difference between these two? Miss, for example, you are representing up to 0.6 and 4 like this. Height of 6 and height of 4 you are representing like this. This is called as frequency distribution. If you are calculating the probability and if you distribute, that is 0.6 and 0.4. Now here, whatever on y-axis is there, count frequency is there or probability is there on y-axis? So probability is there on y-axis, then it is called as probability distribution. If on y-axis frequency is there, it is called as frequency distribution. If on y-axis probability is there, probability distribution. Now this is for discrete variable or continuous variable. So this is called as discrete probability distribution. If it is for continuous, means continuous probability distribution. Clear? This is the meaning of discrete probability distribution. One of the most important interview question. What is meant by discrete probability distribution means representing the discrete variable probabilities on a graph is called as discrete probability distribution. Left on the y-axis represent the probability, on x-axis represent the variable. If you represent on y-axis frequency means frequency distribution. If you represent probability means probability distribution. Done? Now let us go with the continuous probability distribution. Is that clear? Statistics is very dead easy concept, basically. Now if you go with this, now here whatever the weights are there, these are the 20 students weights. Now you are representing the weights on the x-axis and their frequency on the y-axis. So how many 90 to 100 are there? 5 students are there. From 100 to 110, how many are there? 6 are there. 4, 3, 2. So this is with respect to, this is called as frequency distribution. Now tell me, what is the probability of weight between 90 to 100? What is the probability of between 90 to 100? Means nothing but 5 by 20. What is 5 by 20 is nothing but 0.25. If you draw the graph up to 0.25, the height of 0.25. Now this is 5, 6, 4, 3, 2. Now what is the probability between 100 to 110? 6 by 20. 6 by 20 is nothing but 3 by 10, which is 0.3. You write 0.3. Now this is 90 to 100, 100 to 110. From 110 to 120, what is the probability? 4 students are there. 4 by 20, which is nothing but 1 by 5, which is 0.2. What is the probability from a student from 120 to 130? How many students are there satisfying your condition? 3 students are there. Out of 20, 3 by 20. 3 by 20 means which is nothing but 0.15. Next, last one with respect to from 130 to 140, how many students are there in the given data? 2 students are there. 2 by 20, which is 0.1. This is called as continuous probability distribution. This is frequency distribution. This is probability distribution. The histogram will not change. Only the y-axis values will change. X-axis will not change. Histogram bar's height will not change. Nothing will change. Only on the y-axis, the values will change. Now, if you total all of them, what is the total? Sum of the probability is equal to 1. Always it is equal to 1 only. If you go with the discrete probability, whether if you go for continuous probability also, always the answer remains with sum of the probabilities is equal to 1. Simple. This is the data set. This is the frequency distribution. This is the probability distribution. Any questions? Discrete probability distribution, continuous probability distribution. Probability distribution is also completed. Topic is completed. Probability completed. Probability distribution is also completed. If you represent on the y-axis, probabilities means probability distribution. If you represent count means frequency distribution. Only difference both of them is on y-axis what you are representing. What value you are representing on the y-axis. That is the difference between both of them. Is that clear? Done, guys? Now, as one of the student is asking what is meant by conditional probability. Conditional probability that we are going to see during the Naive-Bayes theorem actually, since as one of the student is asking the question, now what is the probability that girls are doing the shopping? There will be some probability. Obviously, they will do more shopping now. So let us go with them only. So what is the probability of girls are doing the shopping? Separate probability is there. This is called as normal probability. What is the probability that they'll do the shopping during the rain also? It is raining also, no problem. I will do the shopping. They'll fix now. What is the probability that one? That is called as conditional probability. This is probability, this is conditional probability. Conditional probability means there will be one condition. Based on that condition, whenever the condition satisfies and we are calculating the probability, that is the conditional probability. And in detail of conditional probability and theorem of conditional probability, we are going to see during the nav bias. Conditional probability means there will be one condition, and based on the condition, we are going to calculate the probabilities. For example, one girl is there. She will do the shopping. The probability is out of 30 days in a month, she will do 23 days, assume. This is shopping probability, 23 out of 30. Now, out of these 23 days, some days will be sunny, some days it will be rainy. Now, out of 23, how many rainy days are there? Assume 10 days are there. 10 divided by with respect to 30 is with respect to that one. Sunny with respect to 13, something. So this exactly the conditional probability detail we are going to see during the nav-based theorem. Okay, based on the conditional probability only, your mails are getting classified whether it is an inbox mail or a spam mail. Gmail is considering the same concept. Okay, Gmail checks with respect to the words, whatever the words are there. These words belongs to a normal mail or these words belongs to the spam mail. For example, if you have written a mail called as lottery, you have won a lottery of 110 CR. Automatically it will send into the spam mail because lottery words belongs to the spam. So it will send into the spam by default. Right? It is checking that what is the probability of lottery word belongs with respect to spam. What is the probability of lottery belongs to with respect to normal mail? Whichever is having the high probability, it is going to send into that one. In that way, the Gmail, it is going to classify the mails. It is working on the conditional probability theorem. And during the nav-based algorithm, we'll see with respect to Gmail classification. That is the project which we are going to work. That we'll see later. Once again, crazy explanation. Thank you. Okay, fine. Clear? Probability distributions are clear. Probability and probability distributions. Continuous probability distribution and discrete probability distribution. So here the same example I have taken with respect to the weights, weights of the students and their probability. And now you are representing this one. This is called as frequency distribution. Here you are having with 5, 6, 4, 3, 2. This is frequency distribution. This is probability distribution. The only difference is on the y-axis you are having frequencies here. On the y-axis you are having the probabilities here. On the denominator it is same. Height of the bars also same. Histogram will not change. Histogram will remain same. Only difference is with respect to. Sir, give some additional questions for in front there is dash festival. You can fill that one. Okay. Now next topic is called as density curves. Now how to calculate the probability on the given data. Right? This we are going to see in tomorrow's class. At the time of explaining what is this yes, both are x and y are positive. Means positive direction means in terms of x increases, y also increases. Both are on the same direction. Exactly. Done? Fine, guys. So we'll meet tomorrow.